Klaus was born and lives in Munich, Bavaria, Germany with his wife and two lovely daughters. He's a mineralogist with a diploma from Ludwig Maximilians University in Munich. His PhD thesis was on high-pressure crystallography. He has more than 20 years experience in electrochemistry and 15 years in respirometry. He's been with WTW since 2001 and is the Senior Product Manager for LabEchem products and OxiTop, which we'll be discussing today.
Well, let's start with it. So, well, the BOD, this is one of the typical oxygen consumption parameters we have. So normally we share them in two groups. So we have the BOD, the so-called biochemical oxygen demand, and we have the COD, the chemical oxygen demand. And if we are dealing with the municipal wastewater, then we normally have a ratio of 1:1. That means the BOD and the COD, they make about 50% of the total oxygen consumption in wastewater. And this is a very important ratio because this gives us also an idea how big the BOD will be, or what we expect here. You know, the BOD, biochemical, that means we are using microbes as living organisms, and they are engaged to deplete the carbon freight. And what we are doing is that we are trying to follow we need their work to deplete the oxygen, and they need some preconditions, of course. And of course, we need also some standardization. And that means that we have some prerequisites if we're doing a BOD measurement. And for this means that we have the microbes, they need a certain adaptation to the environment where they're living. That means each wastewater plant has a little bit different bacteria. And if they will be exchanged, then of course there will be some time that they have to adapt to a new environment. Then we have to make sure that the temperature is stable just to compare the values. Then we need a nice pH, around 7. Bacteria don't only need the carbons, they also need some nitrogens and some phosphate. And of course, last but not least, they need the oxygen. And the amount of oxygen they need for their work, this is what we measure in the BOD, and this is the BOD X, and the X is it's a placeholder because we have tests. Normally we run a BOD 5, but we also have some areas where we have run a BOD 7. And this is a very typical test because we are doing more or less that what the wastewater plant does. We do it in a bottle. And just to get an idea what this biochemical oxygen demand really is, or for what we need it is that we want to get an idea how is the efficiency of our wastewater plant. And that means we are simply comparing that what comes in, the BOD of that what comes in, and we compare it to the BOD that what we have in the effluent. And because it's a parameter that takes some time to be measured, so we are talking normally about 5 days what we use for this measurement. It's of course not an instant monitoring of that what we are doing, but it's a long-term measurement or a mid-term measurement. And by carefully observing the BOD of inlet and outlet, we are able to give some estimation on the process parameters and a long-term adjustment just to get better values in the wastewater. Well, it's a very, very old measurement. So it's I will come to that later on, but we will have just to give you some idea on the standards behind. we have two kinds of BOD where we differentiate. So the classical BOD and the official reporting method is the dilution BOD. That means we have to prepare some dilution series, and that requires, of course, trained personnel. And we are measuring with an oxygen probe, and we have some standard methods. So we have the German or the European standard behind this. We have American standard behind this. Just in the standard methods of the analysis of water and wastewater, it's in the methods 5210B, for instance. And of course, there's also some alternative determination with photometric monitoring. But what we are talking today, and this is the focus, is the so-called respirometric BOD. The respirometric BOD is much more easier to handle and much more simpler, and it's not the official reporting method. So if people have to report the BOD, they normally are forced to do the dilution BOD. With the respirometric BOD, because it's much more easier, we don't do dilution series. We normally use undiluted samples, and we do the adjustment to the different ranges of the BOD simply by adjusting the volume of the sample. Then the second thing is that we do not need a oxygen probe. We do a measurement by pressure, and it's a self-check method. That means everyone can do this very easily on his wastewater plant and see the performance of the wastewater plant simply by comparing the different values. Well, the basic of this of the respirometric measurement is simply that we are doing something with carbons. And if you see the small equation in this picture, you see that we have one molecule of oxygen and we have one molecule of carbon dioxide. You might wonder how to get this, how to do this by pressure measurement. Of course, we need to take out the carbon dioxide, and this is simply done that we absorb it by sodium hydroxide. And that means we need some chemicals. We have inside our bottles a small rubber container, and in this rubber container we have sodium hydroxide pellets, and they take out the carbon dioxide, and this forms a solid precipitation of sodium carbonate, and this will lead to a pressure decrease. And this pressure decrease is what we are measuring, and we can calculate out of some restrictions the BOD directly. And to make sure that we have a well-balanced BOD and that we get really as most of the carbons out of this of the sample, is that we are steering this sample all the time. This is also different to the reporting method. In the reporting method, the samples will simply be put into an incubator and there will be no steering. So, and the steering will only be done when you take out the bottles after 5 days. In difference to that, the respirometric BOD, the samples will be stirred all the time during the 5 days. Okay, what do you also have to consider? So of course, this is something which is in the sampling. You have to make sure that you have mixed samples normally, so you have that you get the typical composition of your source. You have to make sure that the temperature is correct for storing, and so on, that depending on the storage time, there are different standards which describe how you have to store your samples. Then you have to make sure that you have a homogenized sample, and of course, this should normally be done by steering. If you use a homogenizer, it could lead to lower BOD values because some of the bacteria may be destroyed by this. Then you have to make sure that the oxygen concentration is normally at its maximum This is if you are taking samples from open waters, then it's normally not a problem because they are saturated with air normally. And last not least, we have, besides especially in the municipal wastewater, we have ammonia, and ammonia is also an oxygen consuming parameter. That means if we want to have only the carbons, the degradation, then we have to introduce some nitrification inhibitor just to avoid a certain oxygen demand by the nitrifying bacteria. And on the next slide, you see what happens if you're working without a nitrification inhibitor and with, and you will see we'll have an additional process that leads to a certain pressure decrease, but is, of course, it's not that what you want to initially to measure. It's the nitrification, and nitrification is an unwanted effect in the BOD measurement. Okay, whatever is I already pointed out to the pH value, this is important. And of course, you have to make sure that you have no inhibiting or toxic ingredients. This would be inhibit the BOD measurement, and of course, no chlorine or other bacteria killing substances. It's also important if you have the bottles, if you clean the bottles after the test, you never should use aggressive cleaning agents because they will have an influence on the, or they could have an influence on the BOD if there are residuals left in the bottles. So they should normally be cleaned with hot water and a good brush. This would be the best way to avoid that you have left any inhibiting or toxic ingredients in the bottles. Okay, one question ahead. What would be interesting if you are already in this BOD business? What do you currently use for your studies? Which equipment? Michael, you have already some response?
Yes, Dr. Klaus, it looks like about 50% of the audience have responded now. We'll just give a few more seconds for our audience to respond. It looks like just about everybody has responded. So I'll close the poll and share the results. And it looks like most of the audience is using electrochemical instruments.
Okay.
Followed closely, well, others, and 14% at respirometers. So electrical chemical instruments is the winner.
Okay, this is what I expected, because if you have to report the results, it's the classical method to report this values to the authorities if needed. But of course, it uses some efforts. So, but it's also good to hear that we have people in the audience who are using respirometers, and this I want to switch to that what we had up to now, because we were the first company who introduced a pressure sensor based respirometric system for the BOD. And this was the OxiTop, which was introduced in 1995. The reason for this was that we had to replace the old mercury manometers, which were used up to that time. Well, we have much more than 200,000 heads sold during the last 24 years, because this was a very simple to use, easy to use system, and did not require a lot of efforts. So, but after 24 years, you know, this is one of the oldest products we have in our portfolio. So it was clear we had to do something new on this, and we had also to meet the new requirements of the market and of the customers. And so we introduced the Oxytop I, and the Oxytop I has some nice new features which make the measurement of the BOD much more easier. Why? Very simple. And if you go back 24 years and you consider the electronic possibilities at that time, the world has changed really in a great way. Just think of the displays. You can here see a modern graphic display, and at that time we used LEDs, and the LEDs did not even show the right pressure, but they showed some kind of digits, and you had to convert the digits manually in a diagraph into the BOD value by using some conversion factors. And this is now over. We have a direct display of the BOD on the displays. And I will show you some things which will also accommodate the kind of measurement. So the first thing, I was just switch back. You see we have two colors. The color are simply for identifying, for instance, inlet and outlet. We also had this on the old system to have an easy identification by color. So let's say you have the yellow color for the inlet, and you have the green color for the outlet. And here we have now two more modern colors, which are reflecting also some kind of colors we have in our company. So we use gray and blue. So, but the heads basically are completely from the electronic, completely the same. So you are free to switch whatever you want to use for inlet and outlet measurement. So, but again, some nice things. If you have a bigger amount of heads, of course, you want to make sure that you can also identify the heads by themselves. And the first thing, if you switch on a head, you will see that it has a manual ID number. This ID number can be assigned to each head, and it makes it easy for identifying. For instance, you can identify if you have 6 heads, you can assign head 1 to 3 for inlet and 4 to 6 for outlet measurement or whatever. So you have an additionally electronical ID to see what the heads are doing. Then you have a nice menu behind, and you can select the measuring period. So we have the possibility that you can select a period between 1 and 7 days. Of course, the standard value are 5 days. In some areas, as I said in the beginning, we have also a BOD 7. This is due to the old fact that it comes from the mercury respirometers, because when the people don't want to come in the weekend, they started a measurement, let's say on Tuesday, and they the next Monday evening or next Tuesday they read out the values because they don't want to come on the wastewater plant on the weekend. And this is the historical background why we have also a 7-day BOD in some countries. But normally we have 5 days. But even after 5 days, if the measurement stops, all values will be stored in the head. There's no need for coming in on Saturday or Sunday to the wastewater plant. The measurement will simply stored in the head. So then we have the possibility to select different units, and you see units. If I select milligram per liter, then I get the BOD reading directly in milligram per liter. And the pressure readings we have here in hectopascal, delta hectopascal, are also possible, for instance, for checking something, to see what pressure is actually to see a pressure decrease. This is for more or less, say, for testing. And for those, we have still customers who want to stick to the old digit display. This is also possible, but normally not necessary. Then we adjust the sample volume. So once you have adjusted the sample volume to a head, this sample volume will be stored in the head, and it will be used also for the next test. So it makes sense if you assign this manual ID, as I said in the beginning, because then you know head 1, for instance, is always assigned to 164 milliliters. And this will not be changed and not be lost even if you change the battery. These settings remain. The only thing you have to do is adjust time and date, but these basic settings will remain in the head. Then, okay, if you start the measurement, we have a special function. This is the AutoTemp function that makes sure if your sample is between 15 and 21 degrees that you always get correct results, because over a time span of maximum 3 hours, the system is always checking if the pressure is increasing or decreasing. And as long as the pressure is increasing, for instance, you have a sample with 17 degrees and you bring it into the 20 degrees incubator, then of course you will have a pressure increase, and this is recognized by the head, and the head says, okay, as long as the pressure is increasing, I will zero, and then I will wait for another couple of minutes just to make sure that we get that we start the measurement exact at that point when the pressure is decreasing. This makes sure that we have always correct readings. Then, of course, if you want to check your measurement in between, it's possible to see the intermediate results that you can make sure that your measurement is running correctly. Then you can read out the curve. This is also something nice, because then you know, as long as the curve looks good, also my sample will work fine, and there will be no problems with the result. Then after the 5 days, you will see that we have the final result, which you can simply take off the display and put it into an Excel sheet or something like that. And of course, then you can terminate the measurement. If you terminate the measurement, then all the values will be erased from the head, and it is ready for a new measurement. Then we have some additional settings. So we have different languages. Unfortunately, in your case, it will be mostly English. Then we can switch off the illumination of the display. If you switch it off, you will have a better lifetime of the battery, but the battery lifetime is normally, you should work with more than 1 year with your battery during that time. Then what's also interesting, we have a signal LED, and the signal LED, this will display you the current status of the head. So if you have, after starting the measurement, you will see that these LED will flash in blue. And if it flashes blue, then you know the measurement is continuing. After the measurement has finished, then the flashing will turn to green, and then you know your measurement is ready. The heads are ready to be read out. And if you have a red flash, then possibly the battery is low. So it's a signal for you that you have to exchange the battery sooner or later. Normally, there will be no immediate action necessary. You can wait until the measurement has finished, and then change the battery. Normally it's enough that you have no problems with getting your results. And of course you can adjust the display off time. This is also some power saving possibility. ID setting is that what we have in the what I already introduced in the beginning. Then, okay, adjusting date and time. Then we have also an internal function which should never or not be used. This is a setting of the bottle volume. We did this to be safe for the future. The bottles we use for this sets are, we have them since, in the meantime, 25 years. Of course, these are standard bottles, and from a big supplier in Germany, they're supplying this now for a quarter of a century. But in case that someday they will, and you know that the markets are going faster and faster, in case of someday that they will discontinue these bottles and we are forced to introduce a new bottle, you don't have to buy new heads. You simply, then you will be notified and from us, and you will then you are then you can set the new bottle volume, and this is also some let's say of sustainability for the future. So, but never use this in regular measuring mode. This will be led to very special values. Then we have a nice testing function. If you want to check if your heads are working correctly, then we have a nice device which is called Oxytop PT, where you create a defined under pressure, and depending on the sea level, or on the height above sea level where you are, this automatically will set into a certain ratio, and you will see in the display of the head will guide you through this procedure, and after successful finishing, it will report you that the head is working correctly or that you have a problem. Normally in 99.999% it will report you that the head is working correctly. The operating principle we use, so those who are maybe familiar with WTW lab instruments or something like that, we have a simply long press and short press on the buttons, which reveals some menus behind, or terminate something or start something. So normally the short press is always the more important because it's a direct switch to do some action, and the long press will always lead you in some menus behind. Okay, for calculating the BOD, we use this common gas equation. You saw it already in the slide before. This is a little bit more detailed, so you see that we have this common gas equation is adapted to the conditions in a closed bottle. And here you see what's the most important thing is that the delta P, this is the pressure decrease of the partial pressure of the dissolved oxygen. Okay, so let me just summarize a bit. What we have is we supply this menu controlled LCD display just for convenient setting and convenient reading. Then you have this selection of the sample volume to have a direct output of the BOD in milligram per liter, which is the most convenient way to measure BOD. You have this adjustable measuring period for your convenience, and you can directly read off the curve of the display just to control your measurement. You have no conversion anymore, or no conversion is necessary. You have these control LEDs so that you don't have to look when has the measurement finished. It will automatically turn to green after the measuring period is finished. You have this ID number for the identification, and of course these nice robust plastic housings which make it easy to assign, for instance, inlet and outlet measurements. Okay, for those who have already an OxiTop system working, we have everything you have now on hand you can use without ifs and buts. Because you can use your bottles as you have them, you can use your old steering platforms, you can use the nitrification inhibitor, sodium hydroxide pellets, and your thermostatic cabinets. Everything you have, also the overflow measuring flasks we use for adjusting the volume. You can use everything as you have it now in your laboratory available. You only have to exchange the heads. Okay, here the typical spec sheet just to show what we are measuring. So we are talking about a measuring range of 500 to 1250 hectopascal. The BOD measuring range runs between 0 to 4,000 milligrams per liter. Time and days I also talked about. Okay, German is Tage, days. Then your selectable sample volumes. This is adjusted by these overflow measuring flasks which supply. And we are using one battery. It's a CR2450, which is normally easy to get everywhere. So no special battery. It's a small lithium battery. Okay, now I turn back to Michael. So thank you so far for your patience and for your interest. So we can start after that also. If you have questions, please feel free to tell them.
Dr. Klaus, thank you very much. That was a very informative presentation. I know the audience appreciate it. We have plenty of questions that have rolled in while you were presenting. Just a quick question up on the screen for our audience at the moment. Would you like someone from Xylem VTW to contact you to discuss the OxiTop sensors? Yes, please, or no, thank you. Our regional representatives or Dr. Klaus himself will follow up offline with you if you do indicate that you would like someone to contact you. And as Dr. Klaus mentioned, we will shortly begin the Q&A session. On your GoToWebinar interface, there is a box specifically for questions. Simply type out your question that you would like asked, and I will read those out to Dr. Klaus, and we will take them one at a time. Okay, thank you to the audience for responding. I will close that poll. Dr. Klaus, could I ask you to move to the next slide, please?
Yes, this is the last slide. So this is concerning the questions, and also you see the contact addresses. So you see the local contact address of Xylem in Asia Pacific, and you see also my personal email below for questions. And of course, we are looking forward to your questions.
Absolutely. And for those who attended late, just a reminder that this is part 1 of Dr. Klaus's presentation. Part 2 will be held July 9th, and we do invite you to register for this webinar. Registration can be found at www.xylem-analytics.asia. Again, there will be a follow-up email coming approximately 30 to 60 minutes after this webinar, which will include a link to the recording and more information about registering for this second part of the webinar. All right, without further ado, let's jump into the questions. So Dr. Klaus, our first question is not so much about the product, but more about the method. So if respirometry method has been around for 25 years, why has it not gained acceptance as the approved method?
This is a good question. There were several attempts to bring this to the committees, but there are we tried this in the US. We tried this also in our home country, but the interest is not so big from these committees to push this into this method or as the accepted reporting method. We have it here in the Germany and in Austria, for instance. It's this what we call the self-check method. So we have some regulations that the wastewater treatment plants have to do some self-control. And for this self-control, the respirometric method is in fact the important or is the approved method, but not for the official reporting.
Great, thank you for that answer. And associated with that question is, what are some points to consider if I should use the if we should use the electrochemical method or the respirometric method?
Basically, the sample preparation is pretty the same, but of course, for the electrochemical method or for the dilution method, you have to create these dilution series, and this is of course you have to make sure that the dilution ratios and that all fits. This is you need someone who is experienced in doing dilution series, someone experienced lab worker. For the respirometric method, it's not necessary normally, except you have very strongly polluted water, but this is a different topic, and it's much more easier. This is and there's one difference, of course. If you are comparing the results of a dilution BOD and of a respirometric BOD, you will find that the respirometric BOD is higher, and this is clear because in the dilution BOD you have to consider that you have a certain amount of dissolved oxygen in your sample, and if this a certain amount is already depleted, then you're limited. And in the respirometric, you have this exchange between the gas phase, there's oxygen in the gas phase, and the oxygen in the sample, and this, of course, leads to a better degradation of the carbons in comparison to this to the dilution method. So there's some literature available on that. We are just preparing one. It's an old report which is dealing with this, but it shows very clearly and impressive the difference between dilution and respirometric BOD.
Thank you, Dr. Klaus. When can we expect that literature to come out?
Hopefully during the next weeks, we are working on that.
Terrific, thanks. Okay, next question. If the atmospheric pressure changes during the measurement period, does this influence the OxiTop measurement of pressure?
No, because this is a closed bottle, and we are only doing a delta or a difference measurement between the beginning, and so we have a closed bottle. We have the pressure in the bottle is the pressure at we started, and it's not influenced during the measurement.
Okay, great, thank you. Next question, have you done work on struvite precipitation prevention?
excuse me, this is, I did not get it.
Okay, this might be overly technical. We might have to take this one offline. Have you done
Okay.
any work
Yep.
on struvite precipitation prevention?
No, this is not to my knowledge, but please send it. I will check this.
Certainly.
What
Okay,
just to give a better answer.
sure. Let's take this one offline then. Next
Mhm.
question. What is the best way of selecting a sample for BOD analysis?
The best way of taking a sample for BOD, normal. I think there are different standards describing how a sampling or how the sampling has to be done in a wastewater treatment plant. So far I know, here in Germany we are taking a mixed sample, which will be normally taken over a time frame of 24 hours, and then you do this regularly every day, or twice a week, depends on how many how often you want to measure the BOD. But normally you take these 24 hours mixed samples of the inlet and of the outlet, and then you do the BOD measurement on this.
Great, thank you for that. What's the difference between OxiTop I and OxiTop Control?
The Oxytop I is the successor of the old Oxytop system. That means we have no interface to a computer or to a IR controller. It's more or less it's a standalone instrument for the BOD measurement. Oxytop C has more possibilities, and I think I will talk to this on July 9th when I introduce the Oxytop IDS system.
Great. So in our audience, Mohammed, thank you for this question, and we hope that you'll attend part 2 on July 9th to get more information about your question. All right, let's move on to the next question. Is there any option that we can save the curve of our data, an alternative way, instead of reading through the instrument?
No, not with the Oxytop I. Of course, you can take out the daily readings from the display and put it into an Excel sheet and get the curve there. But for a real, or if you want to have a very detailed curve, then you have to switch to the Oxytop IDS system. Then you have more data points available, and then you can do a much more smooth curve. But it's not possible to take out the curve from the display.
Okay, thank you for that. Another question concerning ISO 17025. Are you familiar with that ISO standard?
It's the ISO 7. It's a traceability, or let's say I know this is the standard that deals with reference materials, etc., reference in the referencing of methods and so on, as far as I remember. Or am I right?
So I believe so, yes. The question concerns that standard and how to overcome unrecognized data in this method.
Unrecognized data. So this is, I think we should take this offline.
Fair enough. Let's do that.
Because this is a question which is, there's no standard procedure for this respirometric measurement which falls under the 17025.
Okay, thank you, Dr. Klaus. All right, we're getting close to the end of our webinar. One final question for you. Is OC100 and OC 110 still available?
Unfortunately not. We only have a couple of units left for repair purposes, but it's not available anymore for as spare parts or replacement parts. So it's only for our service shop, not anymore for normal sales.
All right, thank you for that, Dr. Klaus. And thank you to our audience for participating in today's webinar on OxiTop. And again, we hope that you'll join part 2 on July 9th. Dr. Klaus, would you like to close the webinar? Any final words for our audience?
Yes, of course. So thank you all for joining us. Thank you for your interesting questions. I hope I could show a bit of that what we are now introducing. And for those who have more or who want to know more about degradability and to have those who have more demanding tests, I will be glad if we can have them in 2 weeks available for the next presentation about the Oxytop IDS. And I think this could be a good opportunity for them to see a really powerful tool for BOD and enhanced methods. So thank you again. Thank you, Michael, for leading me through this presentation. Thank you for the kind introduction in the beginning. I forgot to thank you at that time. I will be glad to have someone of you again in 2 weeks in our presentation about the Oxytop IDS. Thank you very much.
It was glad to work with you, and you did a great job considering this is your very first webinar. Great job, and thanks again for your time, Dr. Klaus, and we'll see you again July 9th. Goodbye, everybody. Have a great day.
Goodbye.